Welcome back, 6th grade. This video is going to be a little different from our last couple because instead of looking outwards into the solar system, we are going to turn around and look back towards the middle of our solar system. So we've learned that there are all kinds of things orbiting around our sun. Planets, asteroids, comets, inner planets, outer planets, all this stuff, moons. But we have not really talked about what our sun is. Our sun is a star. And what does that actually mean? A star is sort of like a solar furnace that is constantly creating energy. And it has a structure that is somewhat similar to a planet, but it is made completely out of gases. There's no solid core in a star, at least in a normal functioning star. You're going to watch the video this week about supernovas, and when that happens you can get a dense core, but then it immediately explodes. So normal stars are completely made of gases. So let's start in the very center of the star. We call it the core, but it's not solid. In the core there is incredible pressure from the gravity of the star and all the other things weighing down on the core. And what stars are mostly made out of is hydrogen, which is this really tiny element. It only has one proton. It's super, super small. And so that one little element will get pressurized so much that it will actually combine with other ones like it. So you'll actually have what's called nuclear fusion going on, where two nucleuses of atoms fuse together and make a new nucleus. So you take one proton and smash them together to get two protons. So you take hydrogen and make helium. And that releases a lot of energy. It's like a nuclear explosion almost going on all the time in a sun. And that energy makes it also very unstable. So the nucleuses are forced to slam together and release tons of energy, but now they're unstable. And so they'll actually break apart again and become hydrogens again, and that releases energy. So you have energy upon energy being just released and nuclear explosions happening all the time inside the core of the sun. And that's what creates the incredible heat, the incredible light, and the incredible radiation that comes off of the sun. Think about how crazy it is, because even where we are, which is millions and millions of miles away, we can still feel hot outside because of the incredible light and heat coming from that star. So that's what happens down here in the core. In the core is mostly actually made of helium because it's being crushed so hard. Right outside of the core, the next layer out, is the radiative layer. The radiative layer is where you'll find all the hydrogen. So when the hydrogen fuses and becomes helium, it gets heavier because it's heavy. It's twice as heavy as it was before, and that makes it sink down into the core. But when it breaks apart, then it'll raise back up to the radiative layer and will start doing its thing again. So that's where you'll find all the hydrogen. So core is helium, next layer is hydrogen. Then the layer after that is different elements that have been created, heavier elements that sometimes form. And that's called the convection layer, where gases carry that crazy energy from the inside of the sun out towards outer space, and then when they cool, they'll fall back down and then rise again when they get hot and make this convection current that carries the heat of the core out to space and makes it, or allows it to, escape out into the universe. Now, does that seem kind of familiar? The layer that's right above the core that has these convection currents that carries heat up and down? You might remember this from way back at the beginning of the year when we talked about the layers of the Earth. The mantle of the Earth is the same, or does the same job as the convection layer in a star. The mantle also has those convection currents and is carrying heat up and down. So it's really interesting how all these different things, like a star and a planet, have very similar characteristics. Kind of seems like the same person designed both of them. Interesting. So After you have the convection layer, you have the photosphere. The photosphere is what we look at and we see as the surface of the sun. It's not actually a solid surface because it's made of gas, but it's what we see as the surface. So when you look at like a picture of the sun, you're looking at the photosphere. Right after the photosphere is the chromosphere, which is like a haze of orange and red sort of swirling light that covers the sun. And that's where there's some gases, but it's thinner. It's almost like the atmosphere of the sun, but it's the chromosphere. After that, and get this, ironic for our times, after the chromosphere, the larger area of still really hot gases and high temperatures that surrounds the atmosphere of the sun is called the corona. Interesting. So the corona is actually really, really hot, and that's what we can see sometimes when we're looking through telescopes and stuff, is like the really faint haze around the sun, but it's the very outer layer of the atmosphere of the sun. So going from the middle is the core, then we have the radiative layer, which is hydrogen, then we have the convection layer, which is kind of like the mantle on Earth, then we have the photosphere, which is like the crust of the Earth that we can look at, but it's not solid, it's gas, all the way through gas. Then we have the chromosphere, which is kind of like the atmosphere, and then we have the corona, which is the outer layer. So what does this do? The sun is constantly spewing out three things: heat, light, and radiation. So you'll learn more about those in physical science later in middle school, but all three of those do different things, and they look different sort of if you analyze their energy. So there can be sometimes issues in the sun, random collections of energy that just build up to a certain point and then explode. So those are called solar flares, and they are gigantic eruptions, almost like a volcanic eruption, but much bigger. The solar flares will flare out into space and just release tons of electromagnetic energy. So much so that even here on Earth, 93 million miles away, it can disrupt like satellite communication, radio communications on Earth. And that's why NASA will never do space missions in the middle of a solar flare, because the delicate technology on rockets and satellites and stuff can be easily disrupted by a solar flare. So they will not go out or send a mission up during a solar flare. So that's what a star is like. And our star is a medium-sized yellow star. So in your book you can see there's like this whole chart of different star types, from red giants to white dwarfs and all in between. And we are classified as a yellow star. So that tells us a lot about the temperature of our star and what it's made out of, and we can study a lot just using the light that's coming from the star to analyze it. But you'll see more about that later when we learn about spectroscopy in physical science in 8th grade. So that's it for this video.